Recording could not be started. Recording started. Tikiuosi gerai girdisi. Parašykit, ką nors arba pasakykit. Yes. Taip gerai. Okay. Okay. So basically, we have approached the mid of this semester. So basically, we have 2 months past, and you've already delivered one of the tasks. And as far as I know, I still have a few to screen share desktop window. Okay. Application window. Let me share my stuff, your entire screen. So I will be sharing my screen. Okay. So basically for Java technologies, we have went through the basics. 1, 2, 3, 4, 5, 6, 7 topics, more or less. And these included basic construct elements, various aspects of Java technology. So now we will go into the specifics. So today we have design patterns, one of the specific topics in Java. You have already submitted lots of tasks for the task 01. By looking into the list of these tasks, I see that I have to still evaluate 10 of them. Okay, so I didn't have time for that, but I will do this soon, because next week we have the holidays, Easter holidays. So basically you will be, will be no lecture. So you will have some time to rest or to work on a task 2. Well, I will have some time to work on your own evaluating these 10 projects submitted. Okay, so that's good. So for the task 2, we have 3 already submitted, so need to evaluate 0. So basically you have 2 months for that, for the task 2. This is not required. I do not require it to be submitted for the allowance to the exam. As it is said over here, task 2 is optional. Task 3 is optional as well. But if you will not deliver that, so you will miss 2 points for task 2 and 2 points for task 3. So basically, this is an opportunity to get some additional points, because the final exam is 5 points. So task 1 is required, mandatory for exam. The others are not. Okay, so basically this is for the introduction. Now we can go on to the actual topic, and the topic is design patterns. So basically, what we will go through with design patterns in general, I will be showing you design patterns as well as examples, and we will start from the classics. So classical patterns include the ones that were defined by the so-called Gang of Four. 4 guys have defined patterns for the object-oriented programming, and these patterns are being used all over. So basically, we can't miss this when talking about the patterns. And then with some concepts for how basically service locator and dependence injection patterns, as we will talk over as well after we will finish the classics. So I think that classics we will not cover classics in one lecture. We will left it out after the break. But this is not a big deal, because we have lots of lectures left and not that many topics, actually. Okay, so basically patterns, design patterns are heavily used in object-oriented programming, and this is basically one of the key things that a good developer, regardless of which object-oriented programming technologies she is using, because patterns are something that are being used heavily to solve certain repeated problems in organizing the classes. So basically, they are being used, one thing, and the other thing is that various objects, various classes, technologies, algorithms are being called by the classical design pattern name. You would encounter, by looking into the API of various packages of the Java API itself, etc., you would encounter builder, factory, adapter, singleton, and these are the names coming from the classical book, which was written in 1994, first by these four guys, basically Erich, Richard, John, and Ralph. And these four guys have formulated what was at the time known as the design patterns, elements of object-oriented software. Basically, this is quite an extensive book that documents and describes patterns, design patterns used in object-oriented programming. And since they have formulated everything what was known at the time, so they are called Gang of Four, and the patterns are called after them. Okay, so basically, yes, this is what we do, what we will look at today and the next lecture. So basically, design pattern is not something that's used only in object-oriented nor in software only. It is used all over in the world because certain problems just require certain skills and certain solutions. So basically, in general, design pattern is a solution that can be applied over and over again to some similar problem, same or similar problem. So once you have learned, once you have gained an expertise in applying a pattern, you can call yourself as a expert in some sense, or being a manufacturer, right? Because, for instance, designing and building a shoe is following regardless of what shoe it is, right? Because some state-of-the-art techniques being just repeated. So this is what it is all about. Design patterns in object-oriented programming. We have names and they have a certain application for certain problems. So what we will start with Gang of Four patterns, and these fall into the three categories. So categories are recreational. These are the patterns that support the creation of objects. So basically, once you want to create an object, you might consider using the creational design pattern, because people that have encountered into various problems, and these problems basically can be solved by some reusable technique. As well, next category is the structural. Next group is the structural design patterns. These deal with the relationship between portions of application. And the behavioral, so basically these are patterns, organization of classes that influence the state, behavior in a system. Okay, so basically in a broader sense, what we want to do in our application, we just basically want to organize classes in such a way that they would not be tightly coupled. We want our application to be loosely coupled so that we could extend it. So we could add more behavior, we could add more structures, we could add more types, subtypes, etc. So if we would not create an application very, very tightly coupled, we can basically more easier evolve it, extend it into the changing requirements. Okay, so design patterns, at least here at home, I have something like 4 books about that has pattern in its title. So basically, I have a book, this Gang of Four design pattern book, which is something like a 4th edition I don't size enterprise enterprise title. I have a Java Enterprise Edition Patterns book, as well as a distributed service pattern book. So patterns are being used all over in the technologies. So getting familiar with at least the classical ones, which is very beneficial for the good programmer. Okay, so we'll start from the creational design patterns coming from the Gang of Four. Okay, so we start. This is the creational pattern abstract factory, right? So abstract factory is basically a pattern that provides an interface for creating families, we call families, of related dependent object without actually specifying which concrete classes are to be created. So here, here in the scheme, we have a client which uses a factory, and this factory is an abstract one, right? It has an italic. And basically, it has a couple of specific factories, and each factory is working with the specific types of classes. So basically, it can create a product A, it can create a product B, right? This guy, this factory 1, right? And basically, when a client uses a factory, it does not know which type of product A and B is actually creating, right? It just uses factory 1 and it creates A1 and B1. If it would be using a factory 2, it would be creating a product A2 and B2. So these products are somehow related, and factories know how to create these specific products. But what a client does, it basically works only with abstract types. You see, it works only, what it knows the factory, which is abstract, and it takes a handle after the creation from the factory. It takes the handle of product A and product B. What specific product it is, you just don't know, right? Factory does. So what we gain with the abstract factory is that basically we decouple the specific classes and the factories and the objects that create these objects, right? The products. So you can draw a swim line here, right here. You can draw your imaginary swim line. You as the client, something, right? Within creating specific objects. So basically, after drawing the swim line, you can develop your application, your client application working with abstract objects. As well, you can extend the number of products that your application work with independently, right? For instance, you have a product A1, product A2, and you have unlimitedly add product A3, product A4, A5, etc. Because what you will be adding to this application, you will be adding new products, both A and B class, right? And you can add an additional factory. And since you provide with factory as well as products, new types, your client already knows how to do that, know how to use this. So basically decoupling at this level, you decouple not only from the specific products, but you decouple the creation as well. So this kind of an abstract factory is actually quite useful and used in many places in Java applications. Okay, so now let me go to the example. I have some examples. So abstract factory demo. Here is an example. My examples are not always not that actually good. Sometimes I'm not very happy about these examples because some aspects of the design patterns are not being revealed, but despite this, they're illustrative. Okay, so here we have an abstract class, right? Abstract class, and it has a method get shapes, right? Get shapes, so it creates shapes. So we have two types of this abstract factory. One type is an abstract factory of creating round shape factory, right? This creates round shapes, and this creates rectangular shapes factory, right? So we have two types of factories. One is for creating round shapes. Another one is creating rectangular shapes. Okay, so basically now this application, you can consider this static method as application, doesn't know nor about the specific and what to want to inject this and it can shapes, right? Application and how we call we inject factory to use, right? So at one case we inject the round factory, another case we inject the rectangular factory. Okay, so basically by running this app, okay, so basically it uses it without any problems. It just prints out the factory, right? So in one case it was a round shape factory, right? So basically it was capable in producing these shape objects and drawing them. In another case it was a rectangular shape factory, right? And it was capable of two of them. So basically factory was providing just a circle, and another factory provided two types of objects, right? Rectangle and square. So this is how we did. We have defined for ourselves the abstract factory, right? We have two specific ones. And so basically these can be used in the application without specifying the exact shapes and exact factories. So if I would like to evolve this application, right, extend it, I can do that easily without any problems, right? I can basically extend it and use this factory to produce shapes of whatever kind it is. Okay, so and as well, I can easily add new factories, new types here, and inject somewhere when I need a specific factory to be used. Okay, I guess you understood that. So basically, this decoupling from the actual product and its creation is the pattern called the abstract factory. Throughout application, you can find in many cases that factories are being used to create one or the other object. So the benefits on using this kind of pattern is basically it isolates the concrete classes, makes the exchanges of these product families quite easy, right? And yeah. So basically, I guess you understood the swimline, the decoupling, family of products, and the factory. Okay, this was one of the factories that we have looked at from the creational Gangle 4 patterns. Okay, the other one is basically the builder creational pattern, and what it does, it separates the construction of a complex object from its representation. And it allows to create modifications of an object, creation of various modified objects during the creation. So this is, for instance, the client that receives a builder, right? And this builder allows to create a part of an object. Then an object is not complete, then it can add some additional part as well. And at the end, once it is created, it basically, the object itself holds the incomplete object, right? The incomplete object. So once it's complete, you basically call build or get product, and you get the final product that was built, right? So basically something which is complex and you want to create in many steps, you can do this because some steps, for instance, might be missing, right? Might not be needed. Let's take a look at the example again. Okay, so basically this was an abstract factory and builder demo. Yeah, builder. Okay, so here we have a vehicle builder, right? This is a vehicle builder. And this vehicle builder interface has a method, add wheels, add frame, add lamps, and get the result, right? So basically, we have a specific bicycle builder, right? This is bicycle builder. What it does, once you initiate that, it has a method vehicle, right? Vehicle. And for this vehicle, it adds wheels. So basically, it adds 2 wheels, as bicycle has 2 wheels. It adds a frame, right? So bicycle has a single frame. And it adds a lamp. Well, lamps, basically. It would need to add... this is bicycle. So bicycle has a single lamp, right? Front lamp, let's say. And at the end, once it's built, you just basically get the vehicle as by taking the result, the final result. In the beginning, result is just a field, internal field hidden from the outside world. Right, okay. So the other type of builder is actually the car builder. And this car builder has a vehicle as well. And for this vehicle, we need to add wheels. So in this case, these are 4 wheels, right? And the frame is a more sophisticated frame. So we need to add 1 rectangle, another rectangle, 4 rectangles. Yeah, a couple of squares, don't know why, but let's say so. The frame of the vehicle much more complicated. And obviously, each vehicle has a couple of front lamps. Okay. So these are 2 builders. So once we initialize an application, right? So we just basically, for the application, provide a bicycle builder, right? And this application just knows how to build the vehicle, right? So it receives a builder, which is vehicle builder, and it knows how to call add wheels, add frame, and then get the result, right? It did not add any lamps, so we just can add lamps, okay? Builder, add lamps. Okay, we just extend it. But this application that calls the builder and does these items step by step, one part after one part, it just knows how to call this for the abstract builder. And it is decoupled from the specific vehicle it actually builds. So for instance, you have one department which is able to add wheels, another department which is able to add frames, and another department which is able to add lamps. So basically all these departments work independently, and at the end, on the exit, you just get the result, which is a vehicle. Okay, so basically by running that, let's see what we get. So we get printed a vehicle. One, it was a bicycle. So it's composed of 1 rectangle, no squares, 3 circles. Okay, 3 circles. So 1 circle was for 1 wheel, another circle for another wheel, and then for the headlamp. And the car, 4 rectangles, 2 squares, and 6 circles. So basically 4 circles for wheels and 2 circles for the headlamps. Okay, so this is basically the structure of the different vehicles. And these vehicles were created by the builders. And builders are specific to the vehicles. Okay, So what basically we've seen here, it was the builder interface, and we have a couple of specific builders. One was builder for the bicycle, another builder was for the car, right? And the client knew how to use this, right? Knew how to use that thing. Okay, so basically what builder allows, what's the benefit of using a builder is basically it lets you vary a product internal representation, right? We could omit some, for instance, the headlamps are not needed, so we basically do not add this. For instance, if we are creating the race car, usually race cars does not have any lamp, right? Which is on the track, racing on the track. So we can just basically skip that step and we would get the final vehicle without any headlamp. Okay, so again, just like the factory method, it isolates the code for construction and representation, right? And gives some additional control for the client for the so you can, for instance, I don't know, like I said, one of patterns that you will have to use in the second task, and it is a specific specific builder type of pattern. It is called the flow pattern, but flow builder, we will talk about this later on, because now we're just getting through the classics. Okay, so this is called another one, creational pattern. This is a factory method. So factory method basically is a abstract creator a factory, right? Just like we've seen before. But it has some operations that are predefined in the superclass, but the creation might be slightly different, right? The creation of the product itself slightly different, but operations are being shared by the various creators. So this is a different slightly method, which is used in various occasions. And this basically has benefits in contrast with abstract factory, that it allows to share certain operations among the specific creations, that operations are the same. So basically you can share, for instance, adding a vehicle might be shared between different vehicles, right? Vehicles might not be the same, but wheel addition, something like the screw tightening operation, is just the same, right? So for instance, the screw tightening operation can be defined over here up top, right? As it is the same technique for everybody. Okay. So let's take a look into some example if I have one. Don't know how good it is. This is, I think, a factory demo. Okay, so with factory demo, we have vehicle factory. It has a create method, right, defined, and this is a vehicle factory. It creates a bicycle, so everything is being defined over here, and everything defined over here as well. So this is not a very good example. Sometimes I'm not that happy about the examples. So vehicle, okay. So we can have something, for example, we can take this guy, right, this guy, and put into here, right? So vehicle would be shared by everyone. So we just need to differentiate in the creation. And here, for instance, adding wheels would be the same, right? So let's make it protected, void, add wheels, right? So since wheel addition is such a similar operation for all the vehicles, let's pretend so. All right, so enter number of wheels, right? This is number of wheels. So basically we just provide, and now for I equals 0, I less than number of wheels, I plus plus, line for simple iterator, right? So we basically add a wheel. So we basically add a wheel to the vehicle. So here, once we call the create, right? So we just don't need for the bicycle to add wheels. We can call the common method, right? So add wheels, and we need just 2 wheels, not 22. Thank you. We just need 2 wheels. And here for the car, we will need obviously not 2, but some more. We will need 4 wheels. Okay, so I just made a modification. So basically I have improved the demo. So now we have the shared method between the factory. So this method, and what we need just to specify how we organize these shared methods and shared fields, right? That we call create, and we add these guys and return vehicle. Here we return a car. So obviously the problem is that in this case we just can create a single vehicle, right? Because it is being shared, it is being as a field in the class. So this is not good. I don't like it, right? So basically let's do it like that. Let's put it as it was, so we can create multiple objects. But now we need to provide this vehicle object in that method, right? So this is what we do. We just provide it, and this is what we do. We provide it as well, right? So now we can reuse this object and create multiple vehicles, no problem. So basically this is a car. This is a car. Would be a bike. This is our bike. This is our bike. A bike as well, right? So not generic, no generics anymore, because this is a specific factory. We know that we are creating a bike, right? But adding a wheel, we just delegate to the super type, because super types know how to add wheel, no problems. Okay. So again, our application receives a factory, and it is capable of creating, using, maybe riding, maybe driving, whatever. Whatever people can do with a vehicle, maybe even, I don't know, crashing it, right? Whatever. All these things are possible with the vehicles. So basically, this is just a usage of already constructed vehicle, regardless of what subtype it is, right? So we can try running it, run it. And let's see, yep, so we have constructed a bicycle with 2 circles, so 2 circles are 2 wheels, and here's a car with 3 wheels, right? If we have a fancy electric super duper car with 3 wheels, right, so we can change 3 wheels. This is a specific thing, right? So now we run a file, and obviously our car now is 3-wheel car, 3-wheel drive. Oh, cool. So this is something like the before Tesla electric car, right? Because before Tesla electric cars were fancy, funny, and not useful, actually useless, right? So, okay. Let's go forward. I guess you understood about this factory method, because what you need to do, you need just to implement the specific creation and reuse of various operations, fields, whatever is needed, whatever is provided from the super type. And this factory is called a factory method pattern. Okay, let's move forward. The prototype. Okay, so basically the prototype is something when you need to create an object, and for this object, actually a prototype object is being provided. So this is a pattern which I have not seen myself in many places actually being used, but it is a classical one. That's why we need to mention. So what it does, it basically has a clone method, and this clone method basically creates a copy of the provided object. Okay. So basically, this is a creation of object based on the prototype, right? Based on some prototype. And what it does, it reuses the clone method. Okay, so let's look into the example. So the prototype is something which is not heavily, I've seen being used, but maybe you did. If you know, you can tell this. You can say so. Okay, let's see what I have here as an example. So this is some kind of a creator, right? So for the creator, we need to provide the prototype, right? So basically we provide the prototype, so we can define this as being final, right? No, because we can change it, right? So basically here we change it, so we can't make it a final prototype. Yep. So basically we can, for the creator, we provide a prototype. And what it has the create method, which does the cloning, right? It clones products. So basically now we have this creator, we provide a circle, and what we say, okay, create a new copy of that provided prototype and draw it. Create a copy of provided prototype and draw it, right? Then we change it. Then we change it into a square and we call create and draw. So basically, under the provided prototype, it basically is capable of creating new copies, right? So let's try running it. So here it is. Unfortunately, it doesn't say the actual difference. It looks like the same, but what we did, we have actually created two copies. And what we did, we just reused the clone method coming from the super type, right, from the object. Okay, so what are the benefits? So the benefits are this prototype pattern can be used to add and remove products at runtime, specify new objects, obviously, by varying values, right? Maybe reduce subclassing, because by cloning, you basically create just a copy. You do not copy the internals. Okay. And things like that. I don't know, obviously, honestly, to say where this can be used, but we can find out in various use cases. And this pattern is a classical one. So we look into this, the prototype. Okay, the other, I think this is the last one. The last creational pattern is actually the singleton. So you know the singleton very well because you have encountered it in the first task, and we talk about this a little bit. And this pattern, which ensures that a class has only one instance in the virtual machine, and provides a global point of access to that class. It actually, what it does, it ensures that all objects that use an instance of this class use the same instance. So basically, only one instance of this class is actually available, right? So when it's being used, so basically, then you just need one copy. Then you need to reduce the usage of the memory. Then you want not to allow to use many instances. For instance, you want to control to access to some resource, and this resource is very valuable, or you can't have two resources. For instance, access to the database, you might have only one connection to the database and you want it to be shared. So you can control access to this database by using the singleton and so on, right? So there are various use cases for these singletons, and you must know them already because we've talked about them quite a bit. So singleton demo, you've seen this already. This is a classical way of defining the singleton. So basically you have a private static singleton, right, instance. In the beginning, it's null, right? It's null. And basically, you have as well static method to get that instance. And once you launch it, once you call this method, it basically checks if instance is null. And if it is null, yes, it creates a new copy and places it as a static private field for the class. Otherwise, it is already initiated, so it basically returns it right away. Yep, so this is a private constructor. It is required that singletons have a private constructor. So it just says hello on creation initializing instance, right? And this is do something, so it basically prints about itself, right? Some info about itself. So what we do here, we just tell that and simple singleton get instance, so we get access, we call do something, and we call do something twice. And it should say about that this is exactly the same instance of an object. So let's run. Yep, so it's basically doing something, right? Doing something. At first, we were in the main. When we initialize it with instance, this is from the constructor. And then doing something, it says, I'm doing something, right, with this from within this singleton method. And then we have a time somewhere else in the application, we just called the same guy, right? So this is very useful when you want to have only one instance of the object, of the class, and you want to control an access. Okay, so the other way in creating that is the possibility to use so-called the holder singleton pattern. So the holder singleton pattern is constructed so that it has as well public static get instance method, right? But instead of just having the instance over here and calling new, you have a private static class of holder, right, which basically has a static field inside the instance. And this kind of pattern, right, and other things, other methods and usage and call is just the same. So what it does, it basically initializes a single instance. This is obviously because we have a static and static, these guys, right? But we don't need to check if the instance was already created or not. You see this if, right? So this if causes problem in multi-threaded environments, because in multi-threaded environments, you might have two pointers coming into this method, and one have just checked that instance is null and went on creation of this singleton. The other thread might be going here, seeing that instance has not yet been created, and start initializing the instance, the other instance again. So very likely that if this pattern is used in the multi-threaded environment, you would encounter two instances, and this is not safe. So what basically programmers do, if they want to fix that, they do the synchronized, right? The synchronized block here. All right. So basically, we can do the synchronized block on instance, for instance, right? We will talk about the multi-threaded environment, and here is the point where only one thread gets access to. Right, so once the thread comes in, we can do this by this. For instance, this is not allowed. Okay. So basically, once the object comes in, right? Once not the object, but the pointer, the thread comes in, it just basically passes this, and here only one is allowed. So basically, once one thread comes in, you need to check that if instance is equal null or not again, because here is the point, here is the point where only one thread is allowed, only one pointer passes in, so you need to do this check. And you see for a multi-thread environment, we have fixed, it works okay. But this kind of problem is called double check problem. So you have to check for instance being null or not twice. Okay, you might say that, okay, we can get easily rid of this guy, right? We can easily get rid of this guy. Yes, it's true, nothing changes, but now this is the bottleneck for the multi-thread environment. So if we have 100 threads and all threads would be waiting to get the instance, which is already not null, right? And stopping here, so this would just cause a bottleneck for the application performance. So basically this can be solved by the double check, right? Double check. Okay, I'm just removing it because I don't need this. This is not the actual subject today's, right? But to solve this in one go is to basically use the holder pattern. And holder pattern is controlled by the Java virtual machine, because initialization of this class, of the nested class static fields, right? Nested class fields are actually happening only once at first access for that nested class, right? And it is controlled, the access is controlled by virtual machine. So you need to do double checks and things like that. It works right away. So this is the technique that I would strongly suggest to use in your applications because it is multi-thread safe. Okay, I think it was enough said about the singletons. So here is the singleton, and you must already well know where to use it. Okay, so these were the creational patterns. Now we can go into the other group of patterns. This is again classical patterns, the structural patterns. So structural patterns, basically what they do, they control the relationship between the large portions of application. Yeah, so for instance, when you have some incompatible parts in your system, in your application, and when you want these two parts to communicate well, you can use the structural pattern, right? Or you want, for instance, some very complicated structure and application, many classes, etc. You can do what you can do. You can use the facade pattern. This is a specific pattern that simplifies the access to the application. Okay, so basically, let's go through. Okay, this is the first one is an adapter. And adapter acts as an intermediate class between two objects, okay, two classes. What it does, it converts interface from one guy to the other, right? So basically, let's have an example. For instance, we have a client which is capable of calling some kind of object, and that follows a certain interface, right? But on the other application, on the library, which we're about to integrate into our application, we don't have this interface. This interface is just not known, right? So what we do, we create a specific class that does the conversion, right? What it can have, it can have inside itself the object coming from a different class, like here. This is an aggregation, right? No, this is not aggregation. This is composition, I think, right? Because it has the black diamond here. Black diamond means that this adaptee cannot exist without the adapter, right? So adapter has adaptee inside it. So basically, when client is talking to this guy, the client just thinks that it talks to that guy, to the adapter, right? And this adapter covers some specific requests, specific classes, initializations, whatever is needed, by just pretending to be the interface that this guy actually knows. Okay. So basically, adapter is something which is simple. For instance, when you travel to the Switzerland, right, you need an adapter to plug in your laptop, because it does not, the socket wall is not, wall socket is basically not the same. It has 3 pins, right? And pins are laid out in a different way. So in order to actually plug in your laptop, you need an adapter, right? So you an intermediate guy, which basically is possible to plug in your laptop. So this is the client, your laptop, right? The plug coming from the European side, right? And this is a guy which is basically a Swiss socket wall, right? And by using the adapter, you can basically use the wall socket in the different country, right? In Switzerland or England or whatever other country, right? Which has a different socket walls. Okay, and what it does in addition, so basically you can connect incompatible objects, and you can reuse the older functionality, right? If you have some new functionality coming, right, from either side, by creating an adapter, you can basically reuse the old system, the old application, the old style of programming. So for instance, if you have the application which works with the new database API, right? Only new database API, but you want to reuse the old database API, right? You need to create some kind of an adapter, which does the conversion. Okay, so basically, let's take a look into the example. So this will be the different package, I think. Okay, so different package, which is a structural and adapter demo. Okay. Let's take a look at this adapter demo. Okay, so this is a printer adapter, right? This is a print adapter that has a method print, right? So print. And what it has inside, a couple of specific adapters. One is adapter for the HP printer, right? So it has a generic printer inside, right? So this is what it tries to adapt to. This is an adaptee, the generic printer, right? So it basically, once you call the print method here and provide a shape, right? It basically calls the composition, the inside field, which actually has some specific maybe thing, right? And this is a Lexmark adapter. This is the Lexmark legacy printer, right? Which has some additional things which requires some additional operations before actual printing happens, right? So basically print method requires to grab a paper and then do the actual printing. So some additional adaptation things are needed in order to print. Okay, so we have two adapters. We adapt to different guys, right? But then we have a print, the system which is capable of working with this interface, right? With this interface, we're basically capable of printing with whatever printer you would provide, right? So basically, this is an application, print shapes. You just provide a bunch of shapes, and then you provide the print adapter, right? And what it does, just basically simple loops through the shapes and prints them. And whatever is needed for the adapting to the specific printer is being handled by these specific adapters, right? So print shapes with HP adapter, print shapes with the legacy Lexmark printer, right? So basically, this is the list of shapes we're providing, a couple of circles and rectangle, and with different printers we'd like to print. Okay, so let's try printing it out. So we just printed, the generic printer printed the circle, generic printer printed another circle and rectangle. So with legacy printer, we have grabbed the paper for the legacy printer and we printed then. Grabbed the paper, printed, grabbed the paper and printed again. So as you can see, by using these adapters, we basically have converted some specific interfaces to the printer, to the single one, and then we provide it to our application so it's capable of printing, right? Another benefit is not only to be able to adapt these printers to our application, but as well to be able to extend. So now we're not only these two printers. Now we can add some additional printers. Maybe we can even print in 3D printer, right? On the in plastic, we can print these shapes, whatever. And we will not need to change our application whatsoever, because application know how to print and it doesn't care anything about, right? We need to handle all the specific with these adapters, right? So if you want your application to be extended on this way, if you want to actually extend your application at this level, you need to provide the specific interface so that it would generalize the usage for your application. And later on, you can basically extend these adapters in whatever way you'd like. Okay. Okay, this was an adapter. Okay, so the bridge basically is a simple, all these patterns are not something specific, right? But when we formulate them in the pattern notation, right, they seem to be complicated and confusing. But actually, when you are an experienced Java programmer, you're using them constantly. But yeah, talking them separately and in abstract way might be a little bit confusing. So this is an exact example of the specific structural pattern. This is a bridge. And what it does, it divides the complex component into two separate but related inheritance hierarchies, right? So we have two hierarchies. We have client hierarchy, right? We have a client hierarchy that has some kind of an operation, and we have some implementer operation that has a specific operations. And we want to bridge to connect these two hierarchies between them. So what we do, we basically have this implementer used inside, but the abstract implementer, right? The abstract one. So now these two hierarchies, basically the specific client and the specific implementer, can be used in any combination possible together, right? Because what we did, we just basically connected them on the abstract level, right? On the abstract level, they are connected. You can imagine that this client has a field implementer, and this field is an abstract implementer, right? So now what we can do, we can basically extend our hierarchy of implementers. We can add many of these implementers, and we can add many of clients. And still these two hierarchies will be connected via these abstract classes via the bridge. Okay, this makes actually these two hierarchies independent, right? What we have an independent hierarchies as much as possible, of course. They are dependent on the abstract operations here, on the operations here at this level. But the hierarchies, the subclasses, are independent. They can be extended in whatever way you want. Okay, so this basically for extending for improving extensibility and hiding implementation specifics from the clients. Because what we do, we just connect via two hierarchies by using the super types. Okay, let's see if we have a bridge. Okay, so let's take a look. We have some short example where we have a printer, right? This is a printer. This is an abstract guy, right? And this is a specific guy, right? So we have HP printer specific. We have an Epson printer specific, okay? And here we have a shape. And apparently the shape accepts a printer, right? So basically, when we have a shape, we provide a printer, right? An abstract printer. And here we provide an abstract printer. So now, since they are connected in these super types, let's take a look. Yes, so you see the abstract class shape, right? It has a printer. So basically we provided a printer, right? So we can use them. Each shape is capable of to be printed, right? So we can print shape, we can print shape, print shape, and print shape, right? So the functionality of printing for the shape is possible by providing a printer, right? So basically this is how it printed. Okay, so but what's important here is that these printers, right? These printers are very abstract ones, right? Very abstract ones, and shapes are abstract ones. But the specific shapes and specific printers can be extended. We can add additional HP. We can implement something here, right? We can make it a complicated class with many methods, with many properties and whatever is needed. But it would not, this complexity in the hierarchy of printers will not influence the complexity in the hierarchy of shapes. That's the reason of bridges. If you want to bridge two hierarchies together and still want to have them evolved, you want to have them extended over time, for whatever reason, evolving the application, you need to implement the bridge between two hierarchies on the super type level. I hope you understood that. Okay. And this is a simple principle. It is used over in applications many places, but it has a specific name. It's called the bridge, right? So once you talk with professionals of object-oriented programming of Java, for instance, then you can tell them that I'm using a bridge and see the face of the programmer. Most probably they will not know it, right? Even though we'll be using them a lot. Okay, we composite. Composite pattern enables to create hierarchies, hierarchical tree structures of varying complexity, dynamic trees, right? And each element is basically communicate and operate with a uniform interface. Okay, so basically tree structure allows, these objects are represented into the tree structure and compose the dynamic hierarchy again. So what we have here, this is the component, right? The component, you can tell a node of the tree, right? Tree node. And we have two types of tree nodes. We have either a simple leaf, right? This is leaf. You cannot extend it. This is the terminal node in the tree. And this is a composite, right? This is an intermediate, the complex node in the tree, right? And what it has inside, it has a child, infinite number of childs, right? Infinite number of children, many, you can have them, right? And these children are actually components, nodes, right? So we basically can have specific operations for the composant, like adding a node, right? Like removing a node, right? Getting a children and whatever, right? So basically this allows us dynamically runtime create trees, right? So you initialize the root, which most probably is a composite, right? And then you just add childs, and each child can be either a composite or a leaf. So for instance, for the file system structure, you can have a composite is the folder, right? And the leaf is a file. So basically in a file system, you create many folders, which have other folders inside other folders, etc., right? Or we have files, and each file is basically a leaf. Okay, so this is tree structure. And let's take a look into the example if we have one. Composite, yes we do. So what we have here is basically the prototype of the file system. We have a folder. So basically we initialize the root as being a folder. Then to this root we add a file, service.log with some content. Then we have added the etc, right, folder, to the root. Here we have added into the etc. We have added a couple of more files, and we just print the root. Let's take a look. Okay, run file. Okay, as you can see, this was all created in dynamically, right? So printing has happened, I think, in recursive manner, right? So basically, this is a root printed. This is a file at the root printed. Then we have my folder. Okay, my folder. It was okay. Variable was named etc. Okay, so let's have it my folder as well. The variable name should follow what's the name, because I've confused. Okay, so now my folder in the root. Okay, so my folder, it has another file, etc. So now let's take a look into the actual structure of these classes. So the folder, here is the folder. It is a composite, right? It has a list of children, and each children is a node. So is the folder. So basically, we go to the node. We see that it's really abstract. It just has a name and is capable of being printed, right? So this is an abstract method that need to be implemented in the subtypes. So this is subtype of composite. It implements a print, and it does print. Call the print method recursively. It prints itself and then prints each children. Calls print for the children, right? Adding nodes, removing, etc. Take a look. Add an additional one. Okay. Simpler file again is a right, but does not have any inside. It just has a content. And printing is different because the file printing is basically the name and the content. Okay, so this is basically a way to construct the structures. And this pattern was implemented many years ago, and it is called a composite, right? Okay, so for hierarchies, dynamic hierarchies, easily adding new components. So obviously you can extend these components. You can have many different kinds, right? So for instance, for the file system, we can add something like a pipes, links, right? Soft links, etc. We can add whatever we want, right? So many different things. And these would be just extending this hierarchy, this right here, hierarchy. But again, the important thing is that client works with the top level component, right? If the top level component doesn't understand the structure, it might not understand what's inside, right? What types are there? Whatever is necessary for the application, we just do it right here and implement in the specific things like we saw in an example with print. Right, so basically we delegate everything to the subclasses, and we make sure that client does not depend on the specific implementations on the subclass level. Okay, so this basically again and again I'm repeating, this decouples this piece of application from that piece of application, and it makes these loose coupled pieces of application easily extensible. So you can extend one part and you can develop the other part. If you would start in the client using this specific leaf stuff, specific composite stuff, you would actually get into the troubles later on sometime in the developing of application. Okay, so now let's move on again. And this is a decorator pattern. This is the pattern that actually extends behavior of the component, right? So we have a hierarchy of classes. This is a component, abstract one, right? Which is meant to be used by some application. This is a usual component one, right? And this is a decorator, right? This is a decorator. What it does, it pretends to be the usual component, but it adds some additional functionality. And what it has inside inside it has the actual component. It can have a component 1 or whatever other type of a component it can have, right? So basically it hides inside the actual object, delegates most of the operations to that object, but adds some additional functionality, right? So for instance, it can add a state, some additional state, or it can change the behavior or add the behavior. So it basically decorates, it just changes behavior of the component. Remember when we had the synchronized collections, unmodifiable collections, and so on, right? So what we basically had, we had a decorator pattern implemented. So our collection was a normal collection, right? It was a list or a set, etc. And it was wrapped inside of the decorator that prevented modifying methods from being called, right? Once you basically tried to call the modified method, the operation for adding or removing objects, it threw an exception, right? It said, okay, this is an exception. But it just pretended on having these all the objects, items, etc. It had inside the other component. So it basically was acting as a wrapper. Okay, let's take a look into some example for the decorator. Okay, so we have shape, which is a red shape, right? So basically for the red shape, we provide a shape, and this shape goes inside as the wrapped object, right? And then for the red shape, when you call get type, it basically directs here, take the type, right? Here my type is, and the type, it basically says on what it has inside from the field, right? It does not have its own type. It just basically delegates response for the method right from this existing method inside, right? Then you call draw, it just basically calls shape draw with some addition. It says I draw this in red, right? I just draw it in red. Okay, so this is cloning. It clones, super clone, whatever. I don't know why it's used. Okay, maybe it was an example I showed before, whatever. Okay, so basically now we can use this. We can have actually a shape circle, and we draw it, right? So basically this is application. It's capable of drawing a shape which is provided. And here we provide a red shape, a decorator, right? But inside we just plug in the circle, and we call draw shape, right? And this guy just doesn't know that it has some hidden functionality inside, right? It has something changed. It just calls draw as well. It just does not care about internals. So let's run it. All right. Okay, so one was called circle draw in a normal way, and another just called circle draw in red, right? In red. So now, for instance, we can do something additional. So for instance, shape D, shape E, for instance, shape E, draw shape. This is new rectangle, right? New rectangle. So it's different kind of shape, and we just throw into the decorator, right? Throw into the decorator, and it should work just fine. It will draw a rectangle in red, right? So you see, this is a normal circle. This is a circle in red we've seen before, and this is a rectangle in red, right? So whatever we have provided it inside, it just added some additional functionality on top, right? Added something in addition. For instance, we can, just like we had with the unmodifiable, right? Unmodifiable collections. So we can, for instance, throw something here. Throw new unsupported operation exception, right? For instance. So now we just made a decoration, that the thread shape is not drawable, right? Whatever you want, it will not be drawn, right? So basically now you run and it's just not drawable, right? Sorry, it is not drawable, this shape. So if you want to have the, to prevent the shape from being drawn, but it still would be a shape, other methods would still work, for instance, get type, etc. So this is what you need to do, right? To use the decorator pattern. Okay, so this was the decorator pattern. Okay. So basically what it does, it allows you to add more flexibility than just the static inheritance, right? And simplify some added behavior, some extensibility, etc. So these things are all possible. Okay, now the other structural pattern is so-called facade. So facade is very simple pattern. What it does, it basically provides a unified interface to a group of interfaces in a system, right? This is basically a high-level interface so that it makes the subsystem part of an application easier for usage, right? So basically we have a class which makes use of other classes and provides the simplified access to these classes, right? So let's take a look into the example. This kind of facades are being used throughout many places, and they're meant to simplify the usage with application because sometimes it is very complicated. Okay, so for instance, here we have a facade shape maker, right? The shape maker, which is basically what it does, it provides interface for printing whatever number of shapes, right? So basically it collects shapes together, right? It initializes shapes, then it takes the printer and it prints out, right? So this kind of utility that does something about the few classes like printers and shapes, this might be called as a facade, right? Because it basically provides a simplified view to something which is complex, right? So basically by running it as an application, we have a simplified view to something which is complex, right? This example might not be that complex, but in general, this is illustration of some facade with some added functionality, right? So these are very common. Then we have some complicated model. For instance, we are modeling a university. So we have students, we have teachers, we have classes, we have schedule, buildings, courses, whatever, many things, right? So this is a complicated structure. And now, for instance, we want to create a new course, right? So creating a new course it means adding a teacher, assigning a group of students, assigning a schedule, etc., etc. So all this can be combined in the facade pattern. And we could call this facade pattern as, for instance, I don't know, a course creator, right? Course creator. And what it would return us, it would return a course created, right? Which assembles something from the other places. What I have described you is basically more or less mimics the factory pattern, right? Because it creates a new object. So when the new object is being created, better use the factory pattern. But anyway, this is more or less the illustration of a facade. Okay, so basically interface to something which is complex. Okay, we are approaching to the end. No worries about this. One more pattern, let's take a look. Okay, the flyweight pattern. So basically the flyweight pattern is, I don't recall I've seen it anywhere, but it reduces a number of low-level detailed objects within a system by sharing objects. Then in a system, you need to create many small objects. Instead of actually creating, you can share them, right? So basically, you can pretend that you're creating new objects, but actually what you do, you just basically share these objects inside the system. So what you have here is you have the flyweight factory, right? Some kind of factory, which holds a list of objects that are small objects used over in application, like for instance, I don't know, points, right? Some points, etc. So it holds a list, and once you need to create a new object, you basically return what already was pre-created. So this acts like a cache and allows to reduce the number of objects to handle, right? And as well, it reduces the memory storage, memory of a device for application, right? Objects persist in the memory and are being reused, right? So this basically pretends to be a factory, but it actually acts as a cache. Let's take a look at an example. Flyweight. So this is a flyweight demo. Okay, so this is a flyweight factory, right? Flyweight factory. This is a factory that I have. And you can create shapes, right? So basically create shapes. And once you call me, create a shape, right? Remember with the vehicle, we've been creating many circles, many rectangles, many squares whatsoever. And these were exactly the same circles, exactly the same rectangles, exactly the same squares, right? They didn't have any specific properties. So basically, in this case, in this kind of situation, we could reuse this from the cache. So basically, when you call create an object, right, of some type, I basically create it once, put it into the cache, and then return it, right? So I don't need it. So for this reason, I'm just basically holding a map where a type and the object is being stored in the cache, right? So something like this. So now here, basically, I can create, what I do here, I create 1,000 of objects, right? And call it from within the factory. So from factory, I create a random shape and draw it. Create a random shape and draw it. What actually will happen, not 1,000 objects will be created, but just 1, 2, 3. Only 3 objects are possible, right? So this pretends to be a factory. This provides me legit object instance of the type I just asked, but in actual, it just returns what it has got in the cache, right? So basically, by running this guy, we will get a bunch of prints, and these prints are coming from the same object, right? So this is flyweight factory for not polluting the memory with an object which can be reused, basically, right? Okay, so I think we have one more structural, so let's finish structurals for today. It might take a little bit longer. So this is the proxy, the last from the structural group, right? So proxy pattern provides a placeholder object to control the access to the original object. So it looks very similar to the adapter. It looks similar to the decorator, actually. But as you can see, it is on this level, right? So it could actually act on this level as well. So if it would act on this level as well, it would be something of the decorator, or not adapter, but the decorator, right? Adapter would basically hold inside the different type object. It would be an adapter, Proxy, it is just pretending that it is legit object, but it has something inside and it delegates to that. So when does these things are when do these things are being used, right? So in most cases, proxies are being used for lazy implementation, right? So for instance, you have access to the database. You need an access to the database, right? So this, let's say this is the database connection, right? This proxy is a database connection. And this is the real database connection to a Postgres database, right? Connection to a Postgres database. And this one is the lazy connection that has a Postgres connection which is not initialized. So once the client wants to access to the database, right, it says, give me the database connection. It immediately returns this proxy connection, so client's happy. He has the connection, but the actual connection has not yet been initialized, right? It is still on hold. Once the client issues the first SQL statement, queries the database, only then the actual connection is being initialized. So this is a lazy initialization of resources. So this is where the proxy patterns are being used. So let's take a look into the example. So this is a printer proxy, right? That has a printer inside. You see the printer inside. And once it initializes, when it's been constructed, printer is null. Printer is not there, right? It has a name, it is legit printer. It pretends to be a printer, but it is not capable of printing. But once you ask it to print, you say, okay, now print. It basically checks that it doesn't have any printer inside, and it initializes the printer and delegates it, the job, to the actual printer, right? So this is a printer proxy, and then printing a couple of shapes, right? So just in exactly the same example. Okay. So this actually was printed by the generic printer, but what proxy did, proxy pretended to be a printer, right? Pretended to be a printer, but it actually was not. It just basically delegated the printing job to the actual printer, right? So this is what this pattern is telling us, right? So basically, this guy pretends to be true guy and pretends to be able to perform this operation, but actually delegates, right, the operation to the other guy. Okay, these namings are not very precise, but they're coming from the book, actually, more or less. Okay, so basically this is for optimizations, for the lazy initializations, and so on. These proxies are being used. Okay, so behavioral patterns we will talk about next week. And just one hint for you, if you want to start working, I think you will appreciate this if you will spend a little more, and I will talk to you about the interpreter pattern. Because interpreter is something which you have to use for the second task, okay? Because during the holidays, you might have some time to work on the second task. And I want just you to give some hints, some understanding about the interpreter. Unfortunately, we haven't reached this today. It just took longer, but I think you would like to hear about it. So basically, interpreter pattern interprets a language, some syntax, and defines this grammar, right? So basically, it reads the grammar, reads the language of some sort, and interprets it, right? And it's being used to change and extend grammar and to implement it in the programming language. So what we see here is we see an expression, right? We see an expression, and this expression can be a terminal one and not terminal one. And if it is not terminal expression, it has inside another expression, which is called next. As you can see, this is very simple to what we had with the tree structure. And it actually is. Each grammar, each parser actually constructs the program or language in the hierarchy. So it can be broken down into a tree. So basically, this is what happens. This pattern allows you specifically for the task number 2 is to break down the condition, the syntax, right, for the search, because in the task 2, the search is actually encoded in the logical syntax. For instance, x equals 1 and y equals 2, right? So basically, the whole this sentence, x equals 1 and y equals 2, is the non-terminal expression, and it is composed of 2 terminal expressions, right? One expression is x equals 1. This is a terminal expression. Another terminal expression is y equals 2, right? And non-terminal expression is the first one and the second one. Okay, by using this pattern, so basically what you need to do in the task 2 is you need to add the interpret method in the abstract thing and to pass the context, to pass objects that you're about to search at. And then when searching a non-terminal expression, you would delegate a search to its children, right? To its children. So terminal expression would look into the list and find out that x equals 1, right? And would filter only where this condition is met and return. The other end, right, the other branch of the tree would go into y equals 2, would search, would filter out only these values and return. And since this is AND operation, right, this is AND operation, x equals 1 and y equals 2, then you basically combine only the common subset from these two sets and you return. That's it. This is how the interpreter pattern actually works. It basically breaks down syntax, complex syntax, into the tree structure. Okay, let's take a look. Behavioral pattern, and interpreter demo. Okay, so this is the interpreter demo, just like you will have for the task 2. Okay, so we have expression, right? Let's take a look in expression. This is the expression, and this is the top level, as you can see. This is the top level. We're looking into the expression, into this part, right? And it has the interpret method, the Boolean, which says true or false, right? And the context, right, which is provided as an argument, which you need to look at. Okay, then it has the terminal expression, right? So this is the terminal expression. It is an expression, as you can see. It gets the context, right? And what it does, it searches the context. It searches the variable, right, that it would contain some data, which was provided beforehand, right? So for instance, this would be an x, right? And this is just 1. So x equals 1, you just check that your x equals to 1, right? In this case, it is a different task. It just checks that context contains some kind of a substring. Okay, and here, non-terminal expressions, we have 2 of them, right? We have conjunction, where an expressions are provided, right? And it basically, what it does, it is AND, right? Conjunction is AND operation. So it checks that all the expressions within this guy returns true. If any of them returns false, then it means that all the expression is actually false. So basically, if we would have, so for instance, x equals 1 and y equals 2, and we just got that x is not equal 1, then we immediately can return false, because there's no reason to check y, the second part, right? Okay, and disjunction is OR, right? Is OR as well. It is composed of other expressions, right? Of other expressions. So once it receives the context, it passes the context to these terminal expressions, or not terminal expressions, doesn't matter. And what it does, it basically checks that if any of them is equals to true. So exactly, for instance, if x equals 1 or y equals 2, if we find that x equals 1, then we don't need to check anymore, because it is already true, the whole expression, right? The whole condition. Okay, so this is what happens, right? So basically here we construct some example expressions where we will be using in application, right? So for instance, the condition get Ismail, right? So disjunction, right? This is an expression that we have constructed for ourselves. So terminal Jonas, terminal Petras and Antanas, these are all male names in Lithuania, right? And disjunction means or, right? So if we provide some kind of sentence and it has Jonas, Petras, or Antanas mentioned, then means that this is male, right? Now, get is female. We're checking that it is a female mentioned in the context. So again, or Ona, Eva, Laura. We have three names, three Lithuanian female names, and this is disjunction for checking if these names are matching. So now we try to see if two persons can play mix, for instance, in tennis, right? In tennis, we have doubles where two players are playing against another pair of players, and we have two male players playing against two male players. So these are male doubles. We have female doubles, and we have mixed doubles, so that only one female and one male is playing on the same team, on the same side. So now we need a conjunction, right? So conjunction and. So and is male and is female. So we need to check both, right? So that both are true. Okay, so we have constructed some grammar for ourselves. So these were elements of the grammar, right? And this is the top level grammar, right, that we have. And now these are the expressions, just variables for these expressions up top, right? So now we can check. Jonas is male, right? So is male, this is the checkup, and we call interpret Jonas, we pass Jonas, right? Is female, we pass Jonas, right? So we are checking these conditions, and it should return true or false. Is male, Ona. Is female, Ona, right? These are male names, these are female names, right? So we are basically checking the condition. So now this is a more complicated thing. We're checking can play mix, interpret, Jonas and Petras. Can these two male guys play mix? Obviously not. It should tell us false. But can play mix, Jonas ir Ona should tell so. Should tell true, right? So now we're running this, and this grammar is being interpreted. So Jonas is male, true. Jonas is female, false. Ona is male, true. Ona is female, true. Can play mix Jonas and Petras, false. Can play mix Jonas and Donna, true. So basically our grammar works. These are conditions, logical operations that we define for ourselves. And the terminal one, it just basically checks if the context is the string that we've provided contains some kind of data. This is an abstract terminal operation, and the specific terminal operation terminal operations are here, right, with some variables, with some data, and this is just basically a high-level checkup. Okay, I hope you understood that. You can go through again. I just tried my best to explain this, but now task number 2 is basically you have these guys, disjunctions, conjunctions, terminals, etc. defined. What you need to do is you need to go into the expression, top-level expression object, create this interpret, and I think you need to pass to return a list of objects, I think, a list of objects. So after interpreting it, you just return a list of objects that have passed through the condition. And once you did so, your code would look very simple, just like that, right? Because you would be concentrating and dealing with exactly a simple thing which is meant for the specific operation. Oh, I hope I got it clear. So this was the interpreter button, which you are advised to use for task number 2. Last 20 seconds was lagging. Okay, it was a while ago. Okay, so do you have any questions? We will continue after the holidays. MVC. I specifically do not teach MVC pattern. Why? I don't know, because it is used in specific frameworks. I don't teach specific frameworks. We just stick with the pure vanilla Java. And that's why we just need to understand the organization of the POJOs, plain old Java objects at first. We will look into some specifics as well. These specifics are not the ones that are coming from the classics, dependent injection, things like that. But I think that yeah, these are worth knowing. But I think it's already enough knowing the classical patterns. Anything else? Okay, question about task 1. Go on. Pull access or something, you don't need the pull access to provide it, because you actually have to provide in Moodle. Just right here, you go here, right? You go here into the Java course. I hope you can see it. And here you click. And somewhere here, you will have a possibility to provide the task. And as you can see, we have 19 provided. And I still need to check 10 of them. But I've seen that you, Arthur, have sent me by email, right? So no worries. Whatever you've sent to me will be checked. I think it was on time. No, directly to GitHub, no. I think Thomas is requesting that all your data analysis tasks are being pushed to the GitLab. So with Java, it is not the case. With Java, you have to provide the sources.jar file to the Moodle directly. I think we talked about this many times. So yeah, but anyway, you've sent me by email, so I will consider that, whatever you've sent me. Anything else? More concerns? You cannot upload to Moodle? Yeah, now you can't because it's closed, I think, right? Or not? Let me check. So you see what I'm checking. Okay, so this is the configuration. Yeah, the last day is actually okay. Let me put, so we have agreed that you can provide until the end of May. So I will put June 1st, 00 as the deadline for this. But as we have agreed, if you do not put the task until the 1st of April, you will not get any score. But it is mandatory to provide, because otherwise you will not be allowed to exam. So as you can see, task 01 is mandatory for exam, right? But projects that assessed after the deadline does not score points. So basically provided, so this should not be assessed, but provided. So projects provided after the deadline will not score any points. So you just basically would be allowed to the exam, but you'd get 0 here if you would miss the deadline. But as I tell you, I've seen that you have sent me something in the email, so that's good as well. But anyway, you try now to provide to Moodle. It should work now. I will consider that you've sent me your task in time. Okay, anything else? We are late again, but I just wanted you to explain the interpreter. I think you don't mind. Okay, if nothing else, so thanks for being here, and talk to you in 2 weeks. You can send me questions, emails, whatever. Not promised to answer, but we'll try to. And have a nice holidays, stay safe, and talk to you in a couple of weeks.